All right, folks, so welcome back here to the next highlight session done by Chris Lorenzo. Sorry, I almost forget your name. Chris Lorenzo from the US, America. So we are really glad to have you here, that you did that long traveling from all across the sea, coming here to Germany. And the next topic is about polymer in practice, and I'm really curious about that and to get some new knowledge and insight into the polymer framework. So Chris, cool to have you here, and have a great talk.
It's good to be here. Good morning. Wow, nice start to a talk. That's great. So again, this talk is called Polymer in Practice. It's about my experience with polymer. And a little bit about me. Everything that you need to know about me can be summarized in 4 bullet points. 1, I've been married for 5 years to the pregnant lady who's walking around, if you've seen her. We have a son and a daughter. We host 2 international students. We have Max and Abby. And I've been working with Comcast for 9 years now. And it's called Comcast Interactive Media. You may have noticed that, obviously, my daughter was not in that picture. She's expected release date is November 29th. And a relatively new picture of my son, Theo. And, okay, so I come from America. United States of America, I guess you call it here, America. Sometimes you say America and they're like North America, South America. So this is the United States of America. There's 318 million people living there. Probably 2 of the most famous people that you both know or everyone knows. I don't know, one of those 2 will be our president. I'm sorry. Just relative size of Germany to the United States. And now we're going to start off with a little bit of trivia. Okay, so I want everyone to either point to the left, your left, center, or right for where is New York? All right, that's good, that's good. All right, now where is California? Oh, good. Where is Philadelphia? That's my hometown. All right, nobody knows, or very few know. So, New York is the little island right there. California is over here. This is San Francisco is up here. San Diego is down here. And I'm from Philadelphia, which is really close to New York. It's about a 2-hour drive. So just so that you know where I'm from. Philadelphia is a great city. I recommend you come visit it. We have lots of skyscrapers in Philadelphia, which you probably don't know what they are, but they're really tall buildings. I work in the Comcast Center, which is the largest building in Philadelphia. This rendering here is actually a building that's currently under construction. That's the new Technology and Product Center for Comcast. So we do a lot of development there. And for those who don't know Comcast, which is most people from who I've talked to, if you're in the United States, and I give this talk in the United States, everybody knows who Comcast is. They are the largest cable and internet provider. We have 30 million customers. It's a Fortune 50 company, and we also own NBC. I have a picture of the blacklist. Okay, nobody? We just bought DreamWorks Animation, which owns Shrek, the rights to Shrek. People have seen Shrek before, right? Okay. So some of the stuff that the SIM team does is we build a few websites for Comcast. One is the My Xfinity portal. So this is the main portal for our customers. It's just like news aggregation and videos. Next is the My Account, which allows customers to sign in, view their account status, pay their bill online, add users, etc. Yes, my internet and cable bill is $18 a month. That's in US dollars. It's one of the benefits for working for a cable company. You get it for free. We also have a TV portal. This is the Xfinity TV, where you can go online to watch any of your shows via DVR or online or on your iPhone or Android, because we have an app that's an Android iOS app. This is the Xfinity Home portal, which is my team was fully responsible for building. Oh, I have to step back. So the previous website, this one is an Angular 1.5 website. Just want to point that out. This one is written in Polymer now. And Xfinity Home was originally written in Polymer as well. So this was actually our first website that we did in Polymer. And yeah, we're going to talk about that more. There's also an app for that. And so let's get started. Polymer. I have a 5-minute introduction to Polymer for anybody who wasn't at the talk yesterday. It's a native app. So, and I won't touch base on that, but if you want to talk about that later, we are exploring putting web components inside of web views for native apps. So Polymer is a library that sprinkles a little bit of sugar over the Web Components API. Everybody should know what the Web Components API is from the talk 2 days ago. I lost track of time. And it's not a framework, it's a library. The best way to determine whether something's a library or framework is to go to their website and actually see what they say it is. So the big thing that we need to talk about is why web components. Obviously, there's been multiple talks this weekend about web components, or at this summit. It's the big thing. All the libraries are talking about web components or using web components, React, Angular. You're creating these small things. And the reason for that can be summarized by actually on the React page, why choose React? React is all about building reusable components. In fact, with React, the only thing you do is build components. Since they're so encapsulated, components make code reuse, testing, and separation of concerns easy. And that's really what you want when you write code. And so, rather than having all these frameworks building separate web components, the browser platforms have introduced the W3C spec for web components. And what that essentially allows you to do is to create your own custom tags, like my cool new tag. And the web components spec is actually 4 specs: custom elements, templates, HTML imports, and shadow DOM. Custom elements gives you that cool tag name that you can write. Templates is a new tag. It's actually a template tag. You can type it in. And any content that you put inside of a template tag is completely inert to the browser. The browser will parse it, but it will not actually do anything with the markup in there. For instance, if you put an image tag inside of a template tag, the browser will not download the image from the image source. HTML imports allow you to import an HTML document inside of another HTML document, and it also does deduping. So if one HTML import imports another HTML import, which imports another one, and it's already been imported, it won't download it twice. So that's one of the great benefits. And inside of an HTML import, you can have HTML markup, you can have JavaScript, you can have CSS, you can put whatever you want in there. And shadow DOM, not going to talk too much about. I think everybody got a good introduction about that. All right, we're going to look at some code examples of comparing vanilla.js to Polymer version. So you've been warned. I know a lot of people do code. It's appropriate to warn people before showing code, especially in the morning. One other thing to note, Polymer supports IE 10 and above. And their most recent version, they're saying IE 11, but it still works with IE 10. And so here, I've created a web component called myButton, something very simple. And regardless of whether you do it with vanilla or you do it with Polymer, you're still going to have to import the polyfill for web components. And here I'm using the web components light polyfill. This polyfill does not include shadow DOM, because Polymer 1.0 actually uses another thing called shady DOM, which I won't go into too many details about because it's not that important. Styling is exactly the same with web components as you would do with native components. So they work identically with CSS. And here we have the example of how to write it with vanilla.js. And this is using ES 2015 or ES5, but not the ES6 format. So it's a little different than what you saw with the vanilla web components. It's not being processed in any way. And is actually also using the version 0 of the web component spec. They actually changed a little of the calls. But it's done the same way. You basically take an HTML element prototype. You get a created callback for when that element is initialized. You can add click handlers just like you would with a normal DOM element. And then you register the element with the browser to say, when you see my button tag, execute this code with my button tag. Polymer makes it a little cleaner to do it. You actually get another web component to create web components. Pretty cool. But it just has a nice, cleaner syntax. You initialize a component, give it a name, myButton, which matches the DOM module ID. You can set up click handlers. So when the element is clicked, it will call the _click function. And you also get the template tag. So all your markup is contained inside that template tag. You can put divs, paragraphs, whatever. You don't have to do string literals or anything. It's whatever you want in there, and it's completely inert until Polymer actually stamps it into the DOM. And here's just a side-by-side view of the two. Another thing to note, there's actually 3 builds of Polymer. A Polymer Micro, Mini, and Standard, which have different file size and offers different features. I'm not going to go into those different features, but in case you only need a little bit of sugar, you can download the Micro. If, depending on how much sugar you like in your tea, you can obviously download a different version. So the Standard one actually offers a lot of Polymer features. One is the registration and lifecycle. So you get created callback, an attached callback, a detached callback, a ready callback. So there's all kinds of initialization that happens. Behaviors allow you to reuse JavaScript code between multiple Polymer elements. So if you have a function that you want to be included in multiple Polymer components, you can put that in a behavior and include that behavior in another Polymer component. There's utility functions for navigating the DOM. Local DOM is the DOM that's created by the Polymer component, so it gives you methods for manipulating that. And we're going to do a deeper dive into declared properties, events, and data binding. So I'll talk about those in the next slides. And the other great thing that I really like about Polymer is they have excellent documentation, tons of videos to learn Polymer, and as you guys all like here and have been saying, a great community, a lot of good people there. So here's an example of my cool new tag with an error attribute, and this shows the properties. By adding an error, you can actually have a callback that says, hey, if error happens, you get an attribute change event, and you can update the DOM to do something or give it a different look. Here's an example of their click handlers. Well, this is on tap, and this actually works on click and also on mobile devices. So mobile does a touch event. So they created an on tap, which works both for web and also for mobile. But you can also do any type of click handler here, or you can do on-click, on-key down, on-key up, whatever the normal DOM events are. You can just do on-, whatever the name is, and Polymer will register it and call the on-tap handler, or whatever the name of the function is that you want. And lastly, we're going to talk a little bit about how Polymer does data binding. So here I have a user view element web component that I created, and it has 2 properties, first name and last name. And inside the template, I'm putting the first name and last name property in there. And what will happen is when I create that component, I put that component into my HTML, I can specify the property for first name and last name, and it's going to render that in the markup. Good. So obviously, that wasn't as cool as this next example, which is here we have another component called myName. And I'm going to have myName actually produce the variable first name and last name, and I can call this whatever I want. And I put the notify flag on there, which basically says this component is going to produce those values. It's going to share those values with other components. And so now what I can do is I can take the component that I created in the last one, and I can data bind the values of first name and last name from myName into the user view, which gives me the same results. And where this is really powerful is myName doesn't have to have static properties. It can make an AJAX call, get the values of first name and last name from a database, and then give it to the user view to present. And if you want to learn more about data binding, again, there's great videos. Rob Dotson does a whole series called, Polycast. He has like 50-some videos. They're amazing. I've watched almost all of them. And so that was the introduction for Polymer. Now I want to talk a little bit about how we've been using it at Comcast. And like I said, we've been using Polymer for over 2 years now, ever since it was 0.3 version. And the first question is, why did we choose Polymer, right? Everyone should ask that. Why did you choose that framework? Why did you use Angular or React? And so at the time, we were presented with building the Xfinity Home website. And you can see that it makes good use of modules and web components. Like this thing could be a web component. Those button tiles could be a component. You can really see where it could be used. And really, we started this project. We had to build this, and I started looking, okay, there's Angular, there's React, And then everybody has that one developer. Ours is named Phil, and he's the guy who's on the cutting edge. He's reading the latest blogs, and he's the guy who goes, "What about Polymer?" And, I go, "What's Polymer? Nobody's heard of Polymer. Like, Polymer is brand new." That's actually a picture of my son. You always got to throw in pictures of your kids whenever you can. So I had no idea what Polymer was. I looked it up, and we did what every developer should do. We consulted the whiteboard. And we went to the whiteboard and we said, "Whiteboard, what are the pros and cons of using Polymer?" And the first big pro was that Polymer was backed by Google. Obviously, Google's a big player, so you knew it was going to be the future, which is the next point, is its future spec, which we really liked. Web components are going to be built in their browsers, so it's going to get faster and better over time. Great documentation, like I said multiple times. Happy developers. Developers always like doing something new, so they love jumping on board. Cons at the time, Polymer was alpha. We were using the 0.3 version. It wasn't even beta. Selenium did not work with Shadow DOM. If you tried querying an element that was in the Shadow DOM, it couldn't get in there. It was like, I can't find that element. So you couldn't do any integration testing. There was no testing environment at the time for testing web components. Tooling wasn't there. And browser support was IE 10 and above, which wasn't critical for us because we had to use WebSockets, which is IE 10 and above. So needless to say, we went with Polymer because we're crazy. And so as we started working with Polymer, I actually was really nervous in the beginning. And as all developers should be when they first select something, you never know if you made the right choice. And as we were working with Polymer and we were using it regularly, we were like, "Oh, this isn't too bad." And I got more and more comfortable with it. And I'm like, "Oh, it turned out pretty well." And we actually, finished the project. Here's the picture of the devices view. You can, again, see why web components were a great choice for this. This is just an XH thermostat tag. This is an XH light tag in the markup. And all you have to do is put that tag in there and give it some data, and it will display. And the other great part about data binding is if we get an update from the server that tells the light to turn on, it flows down into the front end and updates the light to change to the light on, or it will change it to the light off. So it's getting real-time updates from the server and changing the view automatically. And so we started the project in July 2014 with Polymer 0.3. We went live in May with Polymer 0.5. And as we were going live, Polymer released like a 0.8 version and a 1.0 version. And they're like, "Oh, there's going to be some breaking changes." And so that's the first lesson that we learned is, whenever you develop with beta software, it is subject to change. It was great. I gave this talk a few months ago when Angular 2 actually released release candidate 5 or release candidate 6, and there were 50-some breaking changes in it. And that was between release candidates, so I didn't feel too bad. But shortly thereafter, Polymer actually released a poly-up tool. So this was a tool that would actually go through the 0.5 markup and automatically change it to the 0.1 markup, which is another great reason to use declarative markup. When you're using web components, you're just writing some tag, and it does magic, and it makes it real easy for you to write processors to change it to something else if you need to. All right, so next I want to talk about our development environment. I feel this is really important because I value simplicity, and I want to share how simple our setup is. Some people might argue it's too simple, but I'll let you be the judge. Give me 1 second. Sorry about that. I forgot to mention that it's a 6-hour time zone difference, so it is 5 a.m. for me. It's crazy. Yeah. Come to Germany. It'll be fun. Give a presentation. That's what they said. All right. So in order to write Polymer code, you first need an editor, or at least you should be using an editor of some choice. I use the Atom editor. It's free. I like free. But you can use any editor you want. You can use Notepad. I don't recommend it. Text editor. PHP Storm probably works. Polymer has a CLI tool, so we're not actively using this yet. This is still in beta, but once it comes out, it's something that we'll switch to. This does build for you. It does testing. It does initialization of the project. It does a whole bunch of cool stuff. Really looking forward to that getting done. And then the last tool that we use is the Chrome web browser. We use that for debugging and stuff. And that's all we use. So we're not using jQuery. If you're still using jQuery, once IE hit IE 10, the DOM APIs are pretty much standard across all web browsers. So originally jQuery was important when you were dealing with IE 6 and IE 7 and IE 8, and you tried to do something and it was different in all the browsers, so it kind of made it the same API. But once you hit IE 10, you can just write vanilla JavaScript, which is what we're doing. We're also not doing any pre-processing. The markup that you write for Polymer is exactly what goes to the browser. So we write code, there's no process. Well, you could have browser sync, which automatically updates your browser, but we're not actually changing the markup in any way. And I find that pretty cool. We did have talks about using ES6 or ES 2016, whichever one you want to call it. And we were thinking about doing that, and we still wouldn't need a preprocessor because Chrome actually has native support for ES6 right now with their latest version. So you could actually write ES6 Polymer elements and then only convert it once you do the build process. We're also not using Sass at all, which some people are like, by this point, oh, you're crazy. Sass is a great tool to make things more efficient. And that's true. Except for CSS variables are the latest spec that's built into Chrome and Firefox right now. Safari also has support for it. It's not enabled because Polymer said it was buggy. But this will be available in all the browsers probably within a year. And this allows you to declare variables with CSS. And then other elements can use that variable. Here we're setting the background color to my color. And if that variable is not defined, it will default to the 4285 F4 value, which I think it was the blue color before. So another thing that Polymer gives you is apply. And apply is kind of like CSS variables, except it applies multiple properties. So here we have a mixin name which defines padding, margins, and color. And in my title class, I can apply that mixin, and it will apply all those properties that are defined there. And that's really cool for when you're theming elements and you're creating your own components and you want to set the color, and you just define the variable for color, but then you're like, well, what if another developer wants to change something else? Well, you can just add a mix-in, and then the developer is able to apply any properties that they want to change your component. Makes components a lot more flexible. Another thing that they offer is custom styles. This is basically like importing a CSS file inside of another Polymer element. So you can create one Polymer element which defines basic colors or basic fonts and font sizes, and then you can import that in all your components so they have the same look and feel. So I want to touch base on using the platform. That's kind of the common theme here with Polymer, is they're all about using the browser and what's in the browser and what's coming to the browser. So there's some other platform niceties that we're also taking advantage of that have absolutely no relationship to Polymer. So you can use these without Polymer. And the three major ones are fetch, promises, and cores. How many people are using fetch? All right, Thomas, my buddy here, who's using everything. Fetch, promises. Okay, a couple people with promises, it's good. And cores. How many people know what cores is? You will in a little bit. Good. So, fetch is a modern concept equivalent to XML HTTP requests. It offers a lot of the same functionality as the XML HTTP requests, but it is designed to be more extensible and efficient. Who knows what XML HTTP request is? Oh yeah, that's good. I think everybody knows that. In case you don't know, most people use just $.ajax, and they don't even know what XML HTTP request is. Fetch is basically a replacement for that. It makes it much simpler. You can do the same thing as $.ajax. You can just make calls by saying fetch, the URL, pass it parameters, and it returns a promise. It's also in most the modern browsers, and there's a polyfill if it's not there. So again, like the point is you polyfill it, and as soon as all the browsers support it, you remove the polyfill, you save a few bytes. Promises are the new callbacks. If you've used jQuery before, which I have, and I tried looking through their documentation. Currently, I think they're using done and fail. And if you go back multiple versions of jQuery, I think they changed the response and how you actually handle the return from $.ajax multiple times. So anyway, they use the deferred object, and you would get a .done and a .fail. With fetch, you use .then. So what's going to happen here is fetch is going to make a call to the API URL. When it gets the response back, the then function, the verse then function will be called with check response. So it will get the response. Whatever the return of check response is will be passed into the next function, and so forth and so forth. If any of those functions returns a promise.reject, you skip all the other thens and go right to the catch block. And so you can do nice error handling with that. It's really important that everybody starts using promises or understanding promises, because all of the next browser functionality uses promises. So you really need to understand them well. And it's currently well supported in all the browsers except for IE 11 and 10. So you only have to polyfill it there. Lastly, CORS, cross-origin resource sharing. This is one of my favorites. All right, what this allows you to do, we actually have the Xfinity TV website that I showed earlier. You probably can't see it too well, but the URL for the site is tv.xfinity.com, and the URL that it calls to get data is at xtv.api.cloudtv.comcast.net. And in our line of work, what we have is we have a core team of Java developers who write the API, and that API is used for the web, it's used for mobile, it's used for the X1 platform, it's used for whoever wants to use it. And they get to develop independently of the front-end developers. And because of CORS, we're actually allowed to make cross-origin requests to that API. We don't have to be on the same domain. So it bypasses the same domain origin restriction. And there's simple set headers that you have to set up in order to get that to happen. But it's really great, and there's a lot of great benefits when you separate your API from your web front end, because we actually can do deployments at Comcast for some of the newer sites that I'm working on, and it takes 30 seconds to push out a deployment. So it's great. CORS is built into all the major browsers because you can't polyfill it. It's a security thing. So it's there. You can use it if you need to. So now this is the section that we're going to talk about other Polymer benefits that we've experienced at Comcast. And in order to talk about them, I actually gave a talk a year ago at JSConf, and I called that Polymer the Future of Web Components. And probably a better title would be Polymer the Future is Web Components, because there's so many other people implementing web components now that it's just great regardless of what library or framework you're using. And so during that talk a year ago, I actually showed the Xfinity TV website. And the problem with today's markup in HTML is if you try to write a web application using divs and paragraph tags and H1 tags, you get really crappy markup. And that's just, we call it divinitis. Like, it's just spaghetti soup of markup. And you have all these LI items and buttons and images, and it's trying to describe a poster, like it's a TV poster. And the cool part is that our team actually rebuilt this site in Polymer, and so now you get a TV carousel, and it's a TV poster item. So the markup's actually a lot simpler, and what we're going to do is we're going to look at what this looks like when you're editor. So when you're editing it, we now have TV carousel with TV poster items. So the markup's a lot smaller and a lot easier to understand what's going on, because web components hide a lot of that additional markup that's needed to make things look good. And it gives you a much clearer idea of what's actually happening. And the other great part is, if you want to know what exactly is the TV poster web component doing, you just jump to that file, and you can quickly see exactly what the TV poster is doing. And here we actually break it up into a separate JavaScript, HTML, and CSS file. You don't have to do that. You can have TV poster be one HTML file, developer's choice. And what happens is, when we bring new developers on board to Polymer projects, it's really easy for them to jump in and see what's going on because it's just a matter of looking at HTML, JavaScript, and CSS, which they already know. And Polymer is a very easy library to get started with, and it just takes some time to master, like all great things in life. Another benefit for using web components, as we talked about, is you can share them. So again, a year ago during our talk at the JSConf, I actually had this slide up too, and one of our UX designers came up with, wouldn't it be great if we could take the arm disarm widget from the Xfinity Home website and put it on the My Xfinity web portal. So a completely different site. And I love it when our team actually does those things. So here we actually implemented the arm disarm widget on My Xfinity. It has a different look, which is easy to do with web components because if you build them the right way, you're building components on top of components on top of components. So if you want a different look for one component, you can swap it out with a different component and make it look entirely different. So we were able to add that in there. You can click on the ARM button, and it pops up with the same modal that's on the home.xfinity. You can arm your system. Works great. There's another component on this site that is one of my favorite, which will really explain the beauty of Polymer and web components. This is the Polaris toolbar, well, Polaris Global Nav, and one of our requirements is to put that on every single site that we have. So if you click on Shop, Upgrade, Support, or My Account, you get the same navigation bar. And before we did it, it was a script tag, which would then include an iframe, which would then embed that piece of HTML markup from another third-party team who actually wrote it. And we actually spent the time to convert it to a Polymer element. So now on any site that's using Polymer, we can link import from the site that actually created the Polaris nav, and then it's just a tag. I'm putting XC header in the markup on my page, and I get that same exact nav. And the other great part about that is it's no longer in an iframe, so now it's just another element on the page that I can access with JavaScript. I can change it. I can embed content into the nav if I want to. And the same thing with our footer. The footer is actually shared between all our pages. And we import it with the same one, so you can put multiple web components in the same import file. And now I just have XC footer tag. And that XC footer web component prints out everything on the bottom of our website. Very simple to do, no longer using iframes. But there's also a lot of other great benefits for using web components. Here we have the XC button. Another requirement that we have for our UX is we try to keep our site pretty similar. So how many times have you created a button and you're like, oh, I have to add the CSS and I have to make it slightly different? Well, now you can actually just include the XC button, and by changing the attribute to default, inverted, filled, clear, or disabled, just by adding one little attribute, you can change the look and feel of a button, which is pretty cool. Another great thing is Polymer produces a heck of a lot of web components. I went through a lot of them yesterday. And here's a summary of all of them again. They have app components, which are good for routing, getting the location. Paper elements. We're going to go on paper elements. Here's a summary of all the paper elements, or a lot of the paper elements. They have this navigation bar. They have a dialog box. So the dialog box is amazing. You just do paper dialog, and then you can do paperdialog.open, and it opens a modal. It's great. And then it has all kinds of attributes that you can add to change the functionality of it. You have all kinds of material design checkboxes, toggles, doodads, widgets, gizmos, and doodads to build your next website. So one of the great benefits is if you start a website from scratch and you want to use the material design, you can download these components and you can have a great look and feel for your website for free. So another important part is testing. Everybody should be writing tests for their code. I noticed that was a big theme here. A lot of people ask questions like, how do you test web components? Well, the Polymer team actually created a web component tester. They call it Web Component Tester. There is a great video by Chris Joel to do a deep dive on it. But really shortly, it's really easy to test Polymer components because Polymer is designed with a set of principles in mind: encapsulation, composition, and separation of concerns. So as long as you're writing code to be small and encapsulated, you can test that one piece without worrying about breaking other pieces or having dependencies which are hard to test. And so Web Component Tester actually is built on top of Mocha, Chai, and Sanan. Mocha is the test runner. I think I'm getting this right. Chai is the assertion library, and Sanan is for doing spies and stubs. Great libraries. It's built into Web Component Tester. And they also have plugins for Istanbul, so we actually do test coverage analysis, and I'm happy to report that we actually have 100% test coverage, unit test coverage, which is great. And another element that the Polymer team included is this test fixture. And what that allows you to do is basically every time a test runs in the setup function, you call fixture simple or fixture of whatever the ID is, and it will recreate this element with every test. So you no longer have leaky tests. Every time a new test is run, it will recreate your component from scratch to give you a clean state. And finally, to sum up our testing, we also use Nightwatch for integration testing. There's tons of them out there, but basically all of them use Selenium, so we're using Nightwatch for our testing. All right. So with all great things, there are also some challenges, and Polymer has its own challenges. One of the big ones is encapsulation, composition, and separation of concerns. It's kind of a joke because it's also a positive. But if you've been a developer for a long time on the front end, you write these really long JavaScript files, and that's what you're used to. And everyone has access to the DOM, and it's just simple like that. So we had other teams who actually started using Polymer, and I audited their code, and I checked this out, and I was like, 2,000 lines in one Polymer element. And they just didn't get the memo of making small, reusable components. So really, when you're writing components, you want to keep them small. And the Polymer team actually has a really great example of this. They have this one component called Shop Analytics, and it takes a key attribute, and all it does, and it's actually using document register element, so it's using vanilla. It's not even using the Polymer. The Polymer team's actually using vanilla, too. And all it does is embed the Google Analytics library onto the page and inserts that key as the API key for the JavaScript library. That's all it does. They actually created a component to do one thing. And that's kind of the point. You create components to do one thing and do really well. So the next challenge is libraries. This was great. When we first started, we had to use Moment.js, because Moment.js is a great library for working with dates. And we're like, how do you include a JavaScript library? Because whenever you're working with Polymer elements, you're supposed to have all the imports, all the dependencies defined in the file. And we're like, OK, so if you include a script tag, the browser is going to download that script tag. And then if you have another Polymer component, which is also using Moment.js, they're all downloading Moment.js multiple times. And you're like, what do you do? So we asked the Polymer team, and the solution is, if you have to use a third-party dependency, you put that script inside of an HTML file, and you then import that HTML file. And because imports automatically dedupe, it's only going to load Moment.js once. Cool. Data binding. This is one of the most powerful features of Polymer, and it's really simple to get started, but it's also one of the most complicated pieces. I highly recommend that you watch the video that I pointed out earlier with Rob Dotson. It's the Polycast number 23, and he spends 15 minutes going into how data binding works for Polymer. But just to sum it up with the best practices that we found, we're going to start using Redux in our application, so you can use Redux with Polymer. And you want to create a data store at the top of your page and feed data down into your components. So it's all top level going down into your components. And that way, if there's updates, you're getting them at the top level and you're pushing them down. One of the other things that I like to note is we're doing data components with just JavaScript, not even as a Polymer element. Because what happens is Polymer takes a little bit of time to initialize on the page. So what we do is we write vanilla JavaScript to start making API calls as soon as the page renders, because a lot of our calls actually take a few seconds to get data back for the user. So we make those calls as early as possible, and then we get the data back, and we give it to a Polymer component to expose it through data binding. But here, what you do is you have one single data store, and it's just an object that you're sharing with all the different components. And then you can pass it to another component like a light switch and say, hey, you're datastore.light. And squiggly brackets, we like to use squiggly brackets means that that component is producing the value data store, and square brackets are input. So XH light switch is going to take that as an input value. Data binding arrays are also a little bit tricky. Whenever you get a single object from an array of objects, you need to tell Polymer that you took that object and put it somewhere else, so the data binding system knows to update it. And they actually give you there's a component for that, as the famous quote was from yesterday. There's an array selector component which does the data binding for you automatically. So here, if you have an array of employees and you select a single employee and you want to print that information out, what this does is if you update the array of employees, Polymer will know, hey, I need to update the front end with the first and last name value. All right. Sharing components are also challenging at first. It's not free to share a component. So we have a website, the Xfinity Home website, and it has over 200 components in it. And taking the one Xfinity Home ARM disarm component and dropping on another site for the first time, it took us some time to figure out how to do that. And also because we didn't completely separate our components from the API, we needed to start using CORS headers to make it easy to drop on other sites. So that's one of the first things that you want to do is if you have a component that's relying on data, definitely use CORS. Make sure it's calling through an absolute path or that the path is configurable via a property so you can change it. But don't let it use a relative URL because if you take it from one site and you want to put it on another site, you're going to have to rework it a little bit to make it easier to do it. And the other thing is that Xfinity Home ARM disarm widget has probably about 30 dependencies of other Polymer components. So it's really hard to take that one component and give it to another team. So what we recommend, or at least I recommend, I don't know if it's a recommendation out there, Bower install the whole repo of all 200 components, or do a Git submodule of another project which has a whole bunch of components, and then you can include whichever ones that you want. And during the build process, it's only going to grab the ones that you actually need to put into production. So it's a pretty easy way to share components. Another thing, paper elements. Paper elements are really great if you're going to be implementing material design. We did not implement material design. Obviously, we have our own UX designers who have a different look and feel for everything. And the problem with paper elements, I don't know if anybody remembers Flash back in the day. As soon as you used like one component, you then get all the CSS, you get all the fonts for all the paper elements, which is Google's Roboto font. So you get a lot of overhead if you use one paper element. They're great, but if you're not going to be using the theme for paper elements, you don't have to use them. You can actually use iron elements instead. So every one of the paper elements is built on top of an iron element, which implements all the JavaScript functionality and the core features without the styling. So you can use the iron components. And another way to do it is if you want to use one of the paper pieces, you can actually just fork the paper one and copy the code and change the markup. That's another great thing about components. So if you are interested in starting to use Polymer, where do you go? First, go to the Polymer project website. They have a great Getting Started section. And also check out some sample apps. So Polymer created this shop app to show how to build an actual website using Polymer. It's fully responsive. It uses service workers for offline mode. It's a great way to learn some code examples from the pros. And they also offer the Polymer Starter Kit, which can, again, be found using the Polymer CLI. So you can do npm install -g Polymer CLI, and then you can just do Polymer init, and then it asks you a bunch of questions. You want to init the starter application, and it will create the starter kit. That's another great example. They also spent some time to build a to-do app, because it seems like whatever framework or library, they always have to build a to-do app to show you why ours is better than theirs. So Polymer also created a to-do app, which uses material design. So there's links in the slide that you can check this out later if you want. And finally, use the platform. I think that's the summary here with what Polymer is trying to do with the web, is they're building out these new standards so that the browser is constantly getting better, which is important because we don't want heavy loads going to mobile phones. We want to make it really simple. We want the C platform to be doing as much work as close to the processor as possible, which makes it really fast for users. And so that's it. Any questions? Everyone is stunned. That's great.
How does the search engines understand the new elements or the custom elements?
That's a good question. And I've actually had that question before, which I don't fully know how to answer. There's still Polymer elements, and there's still render in the DOM. And I assume that it works really well, mostly because Google's behind it, and they're a search engine, so they care. But most websites, when search engines check stuff, is they render it first, and then check whether it's doing whatever it has in it. And you can still see all the content because it's not using Shadow DOM.
And what about screen readers and stuff? Accessibility of that?
Yeah, I turned it off and back on, so I'm good. We actually care a lot about accessibility at Comcast. We actually have an accessibility lab, and they've audited all of our sites, and they're completely accessible, all the Polymer components. Again, web components are built on top of native DOM components, so they work the same way as native DOM components, and you can use the same ARIA tags that you would with other components.
You said the compatibility in IE is a little bit limited. How do you solve this, or do you ignore older IEs?
Yeah, I ignore old IEs. We support IE 10 and above. We actually have a few projects which still support IE 9, and because of that, that's why they went with Angular. But I keep nailing our product people like, why are we still supporting this? IE 9 is like 2% of the market. It's really low, and I lose sleep over it. It's worse than jet lag. Yeah, that's the same thing the product people keep telling me. It's still like 1 million people, we gotta support them. That's why, the paying your bill is important, and that's done with IE 9 support. It's the #1 thing, if you have customers.
Okay, thank you very much for having you here. It was very interesting. You will be around. When is your next talk about Polymer and hands-on?
Yeah, so I'll be giving another lightning talk, which will use the same slides, but there's going to be a hands-on session this afternoon. And during that session, I'm not going to be talking at all. There's actually a website called Hackademic, or It's Hackademic, which the Polymer team produced to walk you through building something. And I showed the Google Maps with actually entering a start address and an end address using no JavaScript. And it takes about 20 minutes to build. So it's a good opportunity for you to check out Polymer and spend some time talking to me if you want. And then after that, I'm going to go back to trying to nap.
Okay, thank you very much. We're gonna have lunch now until I think 2 o'clock. At 2 o'clock, I ask you all to be there because we have an announcement to do, and we're gonna continue after that directly with lightning talks. Thank you very much.